All right, we're continuing with the second lesson here. So evaluate each expression, show your work. So we're going to look for PEMDAS steps on what order of operations should I do first. So we're going to do inside the parentheses first. And then within the parentheses, there's an exponent. So 3 squared is 9. So everything else is going to stay the same here while we work on this step first. And then 9 minus 5 is 4. Now we want to do the multiply to get 8 before we do this addition and subtraction. And then we can do this in order from left to right. So 6 plus 4 is 10. 10 minus 8 is 2. So final answer using PEMDAS is 2. All right. Next, we're going to do inside the parentheses first, and again, then we'll do exponents. So 3 plus 5 makes 8. 3 squared is 9. 9 plus 7 is going to end up being 16. And then 64 divided by 16 is just 4. 5 squared is 25. Now let's do all this parentheses first in order. So 12 divided by 2 squared within the parentheses. 2 squared is going to be 4. So again, 12 divided by 4, we do that next. Then we do the 3 times 3 is 9. Then we do left to right for the addition and subtraction. So 25 minus 9 is 16. 16 plus 4 equals 20. All right, the next part is just talking about organizing information in a table, but this table is on the next page. All right, these are the general exponent laws, and then we're going to practice this a lot. So the multiplication law of exponents is when you have the same base and you're multiplying, and that those little exponents are going to add. So I call it the add rule sometimes because we are adding the exponents. So this becomes b to the n plus m. So this becomes 3 to the 4 plus 2, or 3 to the 6. Next is the division law of exponents. This is what I call the subtract rule because we subtract the exponents. So this is b to the top exponent minus the bottom exponent, and therefore it becomes 4 to the 5 minus 2, or 4 to the third. Power law of exponents. This is the power to a power or multiply rule. B to the power of n times the power of n. So b to the n times m becomes 5 to the 2 times 3, or 5 times 6. I'm sorry, 5 to the power of 6. Product law, when these two things in here are multiplying, this little exponent outside goes to everything inside. So it becomes a to the n, b to the n. So this becomes 3 squared and 4 squared, which is really 9 times 16, and you can simplify it further if you want. Quotient law says this little exponent outside showers down to every single level, so it becomes a to the n, b to the n. So here this would become 2 to the third over 5 to the third, or 8 over 125. The rule for negative exponents. Anything that is repeated multiplying is a positive exponent. Anything that is repeatedly dividing is a negative exponent. So this b to the negative n becomes 1 over b to the n. That makes this 1 over 6 to the positive squared. Anything to the power of 0 is 1. So anything to the power of 0 is 1. We will be practicing these a lot in class. Label each part of the diagram and then use your labels to complete the sentences. So we've got a square root This is our radical sign, also known as a square root symbol. And then inside, that is our radicand, or the number under the square root. Sometimes Ms. Sanchez calls it under the house. The expression root b means the blank of b, or the square root of b, and then the radical symbol stands for an exponent of 1/2. The number or expression under the radical symbol is called the radicand. All right, let's go to the next page and look at some practice. Fill in the blanks to complete the rule. Every positive number has 2 square roots, a principal square root, and its opposite. We also call that the positive square root. So for example, I might say that the square root of 25 has 2 possibilities. It has +5 and -5. +5 would be my principal square root, and -5 is its opposite. How is this possible? Well, 5 times 5 does equal 25, and -5 times -5 also equals 25. So both of those are the square roots. So b to the 1/2 is the principal square root, and it has this property. This power of 1/2 times this power of 2, 1/2 times 2 just equals 1. So if I'm saying that something to the power of a fraction times a whole number, remember that when you're multiplying the fraction times the whole number, there might be an invisible 1 on the bottom there. So let's complete this chart to describe the laws of radicals. So when we have something like the square root of 2 factors, the square root of a times b, this can be broken up into the square root of a times the square root of b. Same here, we could break this up as the square root of 3 times the square root of 4, and the square root of 4 does have an answer, so we could say that this is 2 times the square root of 3. By breaking up these 2 factors, we could take the square root of 4, leaving only the 3 underneath. This is called a simplified radical. Quotient law is being able to divide the numerator and denominator up, square root of a over square root of b. So that makes this over here square root of 2 over square root of 5. Now later we are going to learn something that we have to do here. We do not want to leave a square root in the denominator. This is not fully simplified. We are going to learn how to rationalize that denominator. We'll learn that later. All right, simplifying this using these rules. So the square root of 4 over square root of 9 can be broken up to the numerator and the denominator. And then square root of 4 is just 2, and square root of 9 is just 3. This one can multiply these exponents. So 1/3 times 3, remember there's an invisible 1 on the bottom, well that's just 3 over 3 or 1, or you cross-canceled and noticed that earlier. So this just becomes 4 to the power of 1, or just 4. Same thing here, 7 times 1/7, well that just becomes 1, so 5 to the power of 1 is just 5.